Hello people, this is Animesh Das, student of IIT Hyderabad, Electronics and Communication Dual Degree B.Tech and MS, and roll number 2016130, and this is my Science-1 Project-1 video report. So, the project is about finding the survival probability of a rat given its existence in a grid and in a sphere with a cat, given that both are blind, and we have to consider two cases where one wherein they start from diagonally opposite points, and two where they start from the same point. Now, for each of these cases, this is how the analysis will be done. So, ignore all that crap over here. This is the grid here. So, my rat and my cat will have to be first considered to be in diametrically opposite points. That is in case of grid, diagonally opposite points. So one of them is at the origin, the other is at the top right corner, should I say. So this is what we have to consider. That's one case. And second, wherein you saw the grid, there's the center over there. That's where they start from. Now, our assumptions for this project are: one, both of them have a provision to wait at any of the boundaries or the corners, and the probability of waiting for each of them at the corners is half, and at the boundaries it's 1/4. Also, the probability of the movement in all directions is 1/4. This is to be considered so that our probability of movement for each box is the same. Now, with that being considered, let's consider a random walker at any point. Okay, let's take that point as origin, and now it has to traverse to a point n1, n2. Now, the probability that it is at n1, n at the coordinate n1, n2 in the lattice will be calculated as follows, where we take n1 and n2 as points in different number lines. Now, now that we calculated these probabilities, we see that this has to happen simultaneously. So the probability that the walker is at n1, n2 is the same as multiplying these two probabilities right here. I hope you want to note it down. So there you go. I hope it's a bit clear. Thank you. Now, this is what we get if we were to calculate itself. If we were to take that these two events happen simultaneously. Now, the starting points of the cat and the rat won't matter for calculating the probabilities of these coordinates. Now, the actual probability, to calculate the actual probability, what we do is we find the maximum values and the minimum values of these x and y. Now, x max and x min will be n1 and n minus n2 respectively. So the actual probability will be the probability pxy n1, n2, which you saw previously, summed over x running from n1 to n minus n2, because as I previously said, x could minimum be n1 or n minus n2. Now, if the cat and the rat were to start at diagonally opposite points, then this is what will be the probability of them meeting. I think, yeah. So you can note, if you want, you can note this down. And please keep noting. Oh, forgot to mention that. Also, the probability of them meeting anywhere is when you consider n1 and n2 from 0 to m actually, where m is L by R. Oh, also, case 2 is when they start from the lattice center m by 2 and m by 2 comma n by 2, in which case you'll have to consider that we'll have to consider the probability as this. P reach is what you saw previously, right? Now that you find the probability of the rat and the cat meeting, the probability of survival of rat is going to be 1 minus the probability of them meeting. A similar analysis could be done for the sphere problem, for them being on a sphere. Now this is how it goes. Okay, so you consider theta and alpha, wherein theta is the angle made by the point with the z-axis, where z-axis is the line passing through the sphere, through the diameter of the sphere, and alpha is the line made by any point, made by the point, the perpendicular to the point with respect, the perpendicular from the point to the z-axis with respect to some other line crossing through the z-axis. Now what we are to do is find the probability with respect to theta and alpha, in terms of theta and alpha, for each of the cat and the rat, that is each of the entities. Now if you were to find the probabilities, this is how you would go about. I hope this is a bit clear. Thank you. Now our assumptions will be that beta will be small enough so that the helix that the cat and the rat are going to cover would actually cover the sphere, the whole sphere surface. So the probability density function is going to be d alpha and d theta times w of theta comma alpha, and this is how I calculate w of theta comma alpha times d alpha times d theta, and this is how I calculate the probability of them meeting. Now what interests us is how this probability varies with time, and how does this probability depend on each of L and R. L in the case of the grid, and R in the case of the sphere, and also what are the limiting values in case of the step length being too small. So first, the probability of the survival decreases with time because of the increase in number of steps, and this has to happen in both the surfaces. Also, the the survival probability increases with increase in L or increase in R. This is this is because, as you saw previously, this L and R make the probability of meeting vary inversely proportional to their variance. Now, if the number of steps were too large, then this L and R will decrease the probability of meet and therefore increase the probability of survival. So this is how we calculated the survival probability of a rat and analyzed it based on the varying parameters of L and R and the step length. Stay tuned for Project 2 coming up.